Artificial intelligence, when machines think for us. This is a webinar belonging to the Erasmus project Gamification, Digitalization, and Practical Tools for Developing Circular Economy Skills, or CE+. Artificial intelligence is the ability that certain technologies have to augment, through a process of inference or learning, the knowledge initially provided to them. The so-called knowledge-based or expert systems are examples of artificial intelligence. According to John McCarthy, the father of artificial intelligence, AI can be described as the science and engineering of manufacturing intelligent machines and programs. So it's a way to make a computer, robot, or software decide like a human would. To this end, it is necessary to study the way the human brain thinks and the way humans learn, decide, and work while trying to solve a problem, thus using the results of the study as a basis for the development of software and intelligent systems. In the industrial field, the goal of artificial intelligence is to allow machines to perform complex operations which normally require the intelligence of humans to be completed. In this way, machines can replace us in solving complex tasks, not only in the execution of repetitive mechanical tasks, but also in activities that require human experience or skill. However, artificial intelligence demonstrated by machines is different from human intelligence, and its implementation opens up a world of new opportunities for programmers who can create applications in domains as diverse as industrial manufacturing, cybersecurity, energy management, and so on. So, before learning the basics of artificial intelligence, it's essential to understand that it's mostly a combination of reasoning, planning skills, and problem solving. Languages such as Python, R, Lisp, Java, and Prolog are just a few of the many languages that can be used for AI programming and creating innovative projects. Many applications of artificial intelligence now seem to bring us closer to the future. Just think of self-driving cars, Google Translate, or the humanoid robot Sophia. In general, robotics, the automotive sector, and autonomous chairs for the disabled are among the main beneficiaries of artificial intelligence, which makes their control more intelligent, adaptive, and able to modify behavior. However, the use of artificial intelligence techniques introduces a new set of problems related to the characterization of new instruments and measurement procedures. The research is therefore defining and evaluating appropriate methodologies and techniques to identify and specify the accuracy, precision, and reliability of the measurements performed using these new advanced instrumental and measurement procedures. In particular, with respect to the choices of algorithms incorporated in the related software and in the computer system itself. Currently, four types of artificial intelligence are recognized. The first type is that of reactive machines. It is a purely reactive type that does not have the ability to create memories or use past experience to make decisions. Responsive machines are designed to perform specific tasks. For example, Programmable washing machines perform specific functions, but they have no memory. Memory constrained AI, on the other hand, uses past experience and present data to make decisions. Limited memory means that machines cannot come up with new ideas. The memory of these machines is managed by a built in program, and to change their operation, the machines must be reprogrammed. An example is self driving vehicles. The third type, that of the so called theory of mind, includes machines that can socialize and understand human emotions, having the ability to cognitively understand something based on the environment, facial characteristics, conversation, etc. Machines with these AI capabilities are not yet available, but research seems to be well advanced. The future of artificial intelligence lies above all in the fourth type, that of self awareness. Self aware machines will be super intelligent, sentient, and conscious, and will have the ability to react in a very similar way to that of a human being. Regardless of the type, it is so called machine learning that gives AI the ability to learn. This is done through algorithms that offer the possibility of discovering patterns and generating analysis from the data that is presented. But what are some of the typical tasks that AI equipped machines can perform? In general, we can see that machines are now able to perform tasks that could once only be completed by humans, and the complexity of such tasks is increasing. These include, for instance, problem solving, interpretation of visual problems, language recognition, and natural language processing. In the industrial field, one of the most cited applications is certainly that of predictive maintenance, which makes it possible to predict when a machine failure will occur to avoid costly service interruptions. AI can also be used upstream and downstream of these specific predictive models. For example, we find applications in the planning of maintenance and repair operations, generating preventive and predictive maintenance recommendations, analyzing quality aspects, automating operations and routine maintenance using automation software, robots, autonomous vehicles, and drones, interpreting operational data with feedback to service teams, and so on. In manufacturing, AI is employed at various levels, from workforce planning to product design, improving efficiency, product quality, and employee safety. In factories, machine learning and artificial neural networks make it possible to support the predictive maintenance of critical equipment. The use of AI in robotics has led to the concept of collaborative robots or cobots that can be instructed by operators and work with them. AI also makes it possible to automate the process used to request human participation. One example is the Hong Kong subway, where an AI program decides the distribution and scheduling of engineers' work with greater efficiency and reliability than human counterparts. Another example involves Foxconn, which makes most of Apple's products. The company has recently launched an investment plan in AI research and development with the aim of incorporating data collection sensors based on artificial intelligence in all plants and production equipment. The data acquired will allow you to identify maintenance problem and improve production processes. Looking at the future, artificial intelligence is influencing all industrial sectors and beyond. It has been the main driver of emerging technologies such as big data, robotics, and Internet of Things, and will continue to serve as a technological innovator for the foreseeable future. This was the end of the webinar. Thank you for following.